Hello there and welcome to this Pandas challenge. This is day 12 of 30. My name is Valentine and I'll be your instructor. In this challenge, we are going to be doing just the normal thing that we've been doing in the past few challenges. So that means just practicing more about just the concepts in relation to the Pandas library, which we can use for data manipulation and analysis. So let's get started. The first thing that you need to do is to visit the description section of this video, and you should get a practice resource link that should take you to a page that looks like what you're seeing on your screen. And then once you get there, click on the sample practice resource link that should take you to a page that looks like what you're seeing on your screen. Right. If you're an Afterwork member, you could always consider the practice notebook. So if you visit that link once you've logged in, you should be able to get to a practice resource page that will give you access to the practice notebook. And the practice notebook will contain a whole lot more challenges than what you have in the sample notebook. And you also get some solution notebook that you can verify your answers that you've written for the challenges. Right, so once you get to your sample notebook, you can go to File, then Save a Copy in Drive to save a copy of this notebook to your Google Drive so that you can make changes or just review the changes in the future. Once you do that, the next thing that you need to do is to get started. So let's go through the prerequisite. So run the first code cell. It should take you a few seconds, or if it's your first time doing this, it should take you maybe, a few seconds, maybe 15 seconds or so. By the way, feel free always to pause the video and then rewind just in case I'm too fast. So once we've imported the prerequisite, let's now go through the first section. So the first thing that we're going to learn is how to just calculate summary statistics. So sometimes you might want to get some summary statistics such as median, standard deviation, range, count of the numerical variables that we have in a data set. So in the case of this example, we might have this data set that we have here, but we might want to just calculate the summary statistics. So we use the describe function. We apply it to the data frame that we had or we have, and then that will give us a table, which is what you're seeing over here. It's a data frame that contains the numerical variables as well as the respective measures as per the what has been mentioned on the left hand side. So like in our case here, it means that we have 75 values in the product ID column, the same case price, the same case stock quantity. But if we had maybe 74 or 73, it would mean that the count of values in those columns is different than the ones that you have in other columns, which would mean essentially they are missing values. So yeah, so that's it for that. Pause the video and then work on the challenge. The challenge, you'll note, requires you to work on the mode, which isn't listed here. So for that, you will need to, first of all, specify the column that you need to specify, which we've gotten to have covered that in the past. But again, you'll also get to use the mode function, which is just mode and square brackets. And you also need to use, not square brackets, parentheses, then mode, parentheses, then you'd also need to use square brackets. So it would, for mode, it would be this function, and this is what you would need for mode. You'd apply this to the specific column that you want to calculate mode for. Pause the video and then work on the challenge. In some cases where we have a research question and we realize that we do not need all the columns that are in a data set, then we can decide to drop those columns that we don't need so that we have a data set that has columns relevant to answering our research question. So let's learn how to drop a column. So assuming that we had this data set that you find here, we can say that, this, based on our analysis, we might decide to say that, okay, maybe supplier, it's not a column that we need in our data set. So how do we drop the supplier column from this particular data frame? So we apply to the DF data frame the drop function. So we use the drop function and specify the column as the first argument of the value, and we set access to 1 to specify that we are working with columns, that's what we want to drop, and use in place to true to be able to make changes to the original data frame. So here we're going to drop the supplier column, but if we wanted to drop multiple columns, we would use a square bracket, and we would have all the definition of the columns that we want inside the square bracket or inside the list. So that's the first item, the second item, maybe price, etc., depending on the research question that you have. it's good practice sometimes to also save what you have here, the new data frame, in a new variable so that you don't make changes to the original one. But again, you could always just leave it as it is. So in our case, if I load this, I should be able to get a data frame that does not have supplier column. Right, pause the video and then work on the challenge. In some cases, we might want to sort a data frame by a particular column in ascending or descending order. So that's what we're going to learn how to do here. So here, this is our data set, and we would want to sort it. This data set that you see here, want to sort the records by brand, the brand column over here in ascending order. So we can use the sort values function. So sort values is just a function that we use to sort the records based on a particular column or multiple columns. In our case here, we are learning how to sort by one column. So we use the by parameter inside or in, that's provided by the sort values function, and set its value to the column that we want to sort the records by, which is brand. And then we set the second parameter ascending to a value that's either true or false. In our case, we're going to set it to true to mean that we want to sort the records in ascending order. And yeah, that's it. We save the outcome inside sorted df and display it. You can see the records are sorted by brand alphabetically. All right, pause the video and then work on the challenge. In some other cases, we might want to derive new columns, create new columns out of existing columns. And there are multiple ways that we can be able to achieve this process, but we can use a method called the assignment method. So assuming that we had this data set that contains products data that you should see. All right, so that's the data frame. And to be able to create a new column called, say, total sales, that's derived from price and stock quantity, we can use the assign method as, we use it, we apply it to the df data frame. That's the data frame that contains our data. Then inside it, we specify the new column name, and we set it to equal to the operation that we see here. That would be price column times quantity, stock quantity column. And we preview the output. All right, pause the video and then work on the challenge. In cases where we have duplicate rows in a data set, and if we want to drop them, we can use the drop duplicates functions as shown here. So first of all, we load our data set. And then once we have done that, we can decide to remove those duplicate rows based on just the columns. So by simply applying the drop duplicates function to the df data frame. This assumes that a duplicate would happen if all the columns are equal. But if we wanted to only define that, we would have, if we wanted to define a duplicate as a record that has only two columns equal, such as maybe category and brand, we would need to specify those columns using square brackets here. So, this is, we would define a Python list inside the drop duplicates function, and that would be it. So let's drop our duplicates and store the output in df no duplicates function. Pause the video and then work on the challenge. In cases where we want to select maybe records quickly, but maybe even using a certain range, and it would select all the records, but again, we can also specify columns as well. We can use the iloc method, but this method uses what is called index position. So in our case, assuming that we had this data set and wanted to slice or to select the records and maybe the first 5 records, we could use the head function in this case, but we can use the iloc method where we apply it to the df data frame, and inside its square bracket, we specify the index of, or the range that we want. In our case, we want from index 0 to the one before 5. So index to, this would select the first 5. If wanted to select the first 10, this would be 11. All right, and that. All right, pause the video and then work on the challenge. In some cases, we might want to create a pivot table from a bigger data set or summary table, and that summary table we would want maybe to have multiple categories. So maybe category for this particular data set that we have here, this is the larger data set, we might want to have a pivot table with category, then brand, then price, then stock quantity. But now the price and stock quantity for each brand, we would need to have sum of that, so that we have the sum of the price for each brand and as well as the stock quantity. So how do we do that? To create that pivot table, we use the group by function. Here it's like just aggregating data generally. We use the group by function and define the two categorical variables that we want. That's category column and also brand column, and then the respective numerical variables that we want to use now, the price and stock quantity, but we want the sum, so we apply that to that case, and then we apply reset index at the very end to get a pandas data frame format that we can further process. So this is our output. Pause the video and then work on the challenge. Okay, in some other cases, we might want, instead of getting all the records, we might want to specify maybe some conditions. So we might want to specify maybe for this particular data set, we want records where the price is greater than 100. So maybe just for those records. So we use Boolean indexing, as I think we've practiced before. So we specify the data frame, then inside the df, inside df, we specify the condition as shown. So this just refers to the column price, and we use an operator greater than to specify that we want to select records with price greater than 100, and we store the output in filtered data to display the filtered data. Pause the video and then work on the challenge. In some cases, we might want to, instead of numbers, like you can see here, we can decide to put strings, but again, we can use a different method to just be able to extract maybe, or to search for maybe records with some sort of string. So for example, if we had this data set and we wanted to get, this is the data set, and we wanted to get products that have maybe the product name that has maybe the word smart, whether it's a smartphone, smartwatch, maybe smart TV, we could decide to use, again, the approach for Boolean indexing. The only thing that would be different is the condition that we work with. We would first of all specify the column that we want to have the condition for. So product name, and we apply the string contains function. So the contains function from the strings module, and inside it we would define the string. That's the specific string that we want to use for the conditions for searching. So that's smart, and we set case to just false to mean that we want either capitalized or any sort of variation of what we have, either capitalized smart or a mix of letters which are either capital or lowercase there. And then we store the output in filter data and display that. All right, that should take us a few seconds. All right, there you go. Have product name. Yeah, we have 3 records. Pause the video and then work on the challenge. Lastly, we can decide to apply a function element-wise, a custom function. So assuming that we wanted to apply work with a custom function to apply it across each and every value within a column, we can use the approach that we're going to learn here. Just uses the apply method. So initially, if we had this data set, and in this data set, it just contains products information. Assuming we wanted to create maybe a new column that contains price in euros. This is price in USD. So or even your local currency, we can define a function to be able to perform that conversion. So in our case, USD to euros, then that function will take in an input. Inside the function, we define the exchange rate, then we return the operation price, the output of the operation price times exchange, and that would be what we would have. And to apply this function to each value in the column, that's element-wise, that's in the price column, we use the apply method, and we apply that and store now the outcome of this operation inside price euro, and we display the output. All right, pause the video and then work on the challenge. Okay, so that's it with regards to this challenge. I hope you're able to practice a bit more. And if you did find this challenge as well as video useful, be sure to, and valuable, be sure to give it a thumbs up. It tells us that we're doing a good job, and it also tells people that this is a good resource. If If you'd want to be informed when we post the next challenge or other challenges, be sure to subscribe, and see you in the next challenge. Bye-bye.